In this video, we're going to explore a second point of concurrency called the centroid. In order to do this, you're going to need your compass and straight edge, just like with the last video on points of concurrency. In this video, though, we're going to go ahead and use our compass and straight edge to construct the three medians of the triangle below. Like we did in the first video, we're going to make sure that we do this carefully and with precision. Now, before we can construct a median, it's helpful to remember what a median is. Recall from our work in the previous part of the unit that the median is any segment that connects the midpoint of a side to the opposite vertex. So we might say each median joins midpoint to opposite vertex. So in other words, we're going to need a construction that will enable or allow us to find the midpoint. So I want you to think for a moment to yourself, which of our constructions that we've learned so far this year would enable us or allow us to find the midpoint of a side? If you're thinking perpendicular bisector, I really like the way you're thinking, because the perpendicular bisector of a line segment will always pass through its midpoint. So in order to find midpoints, I'm really going to construct some perpendicular bisectors. So let me go ahead and grab my compass here. You should grab your compass at home as well. And I'm going to begin or start by going ahead and constructing the perpendicular bisector of side AB. And again, I'm going to do this carefully and with precision, because I know that ultimately some really cool things are going to happen with respect to these midpoints and the perpendicular bisectors. And I really do want to make my constructions as precise as possible. So make sure I put the point of that compass exactly on point A. I'll get my compass out of the way for a minute. Now recall that when we're doing this construction, the only purpose for doing this construction is to find the midpoint. So what I'm going to do is I'm actually going to use a dotted line to connect the arcs here in my construction, because that dotted line is actually my perpendicular bisector. And the only reason I wanted to construct the perpendicular bisector was so I could find the midpoint. I'm going to call that M1, because I'm actually going to find three different midpoints as we work through this particular construction. So I'm going to call that midpoint 1, and I'm then going to use my compass, or I'm sorry, my straight edge in order to connect midpoint 1 to the opposite vertex. So I'm going to go ahead and use my straight edge in order to connect midpoint 1 to vertex C. And that line segment that I just drew that connects midpoint 1 to vertex C, that is a median. Maybe I want to label this here by its name. He's a median. Now I need to go ahead and I need to do the same thing for side AC. So I'm going to go ahead and use my compass and straight edge in order to construct the perpendicular bisector for side AC. And again, I'm going to do this carefully and with precision. Go ahead, get my compass out of the way. And again, recall that our only purpose in constructing the perpendicular bisector is to find the midpoint. So I'm going to do that line dotted like I did the first time. And I'm going to call that point of intersection now M2 for midpoint 2. Once I know exactly where the midpoint is, then I'll take my straight edge and I'll join or connect that midpoint to the opposite vertex. So in other words, I'm connecting midpoint 2 to vertex B. And that represents a second median in my triangle. And now I'm going to go ahead and construct the third median of my triangle. In order to construct the third median, I'm going to go ahead and begin by constructing the perpendicular bisector of side BC. And I've got different colors. If there's a way for you to use different colored pencils in your compass, that's going to be really helpful, because if you couldn't already tell, these constructions are pretty detailed, pretty involved, and there's a lot going on in the picture. Again, when I construct a perpendicular bisector, I'm going to use a dotted line, because my only purpose in constructing that perpendicular bisector was to find the midpoint. You probably couldn't predict this, but I'm going to label that one midpoint 3. Now I'm going to take my my straight edge, and connect midpoint 3 to the opposite vertex, to vertex A. And that line segment represents the third median in my triangle. So I'm going to go ahead and label that one with the word median as well. And notice that just like with the circumcenter, the 3 medians of a triangle all intersect at one point. That one point where they all intersect, I'm going to call point X. And like the circumcenter, the points of intersection of the 3 medians of a triangle have a special name as well. And that point where the 3 medians of a triangle intersect is called the centroid. So there's your new vocabulary word for the day. The centroid is the point of concurrency where the 3 medians of a triangle intersect. The next time that you come back to class, again, we're going to do some really cool things on the Inspire that will let you play around with the median and do some experimentation and see what happens with different types of triangles. Like the circumcenter, there are some special properties that go along with the centroid that you need to be aware of. I think probably the easiest way for kids to remember this is that the centroid has this whole idea of a 2-to-1 ratio going on. In other words, the distance from the centroid to a vertex is always going to be twice or double the length of the distance from the centroid to a midpoint. And we'll talk more about what this looks like in the picture in just a minute. So the distance, this ratio, or the first part of this ratio, the 2 part, represents the distance from the centroid to a vertex. The smaller part of this ratio represents the distance from the centroid to the midpoint. All right, so I'll give you a minute to get that down on your paper. And then we'll go take a look at what that means in the picture. So if I look at every single one of those medians, I'm going to go ahead and highlight this first median blue. So if that's my first median and point X represents my centroid, then in other words, the distance from vertex A to centroid X is always going to be double the distance from centroid X to midpoint 3. So distance from A to X is going to be 2 times the distance from X to midpoint 3. And I can do the same exact thing for each and every one of those 3 centroids, or 3 medians, excuse me. If I go back to the picture and look at that red median, again, the distance from the centroid to vertex C is going to be double or twice the distance from centroid X to midpoint 1. And if I go back upstairs to look at the picture once again, I'm not sure if I have any other neat colors that I can make the third centroid of this triangle. We'll go with a pink dotted segment. So that pink dotted segment now represents my third median. The distance from centroid X to vertex B is going to be double the distance, or twice the distance, from centroid X to the second midpoint. All right, one other really cool feature of the centroid is that it's the center of balance for a triangle. And we're going to talk a little bit more about what that means and do a neat activity regarding the center of balance the next time that you come back to class. But in the meantime, I think that's quite enough to wrap your brain around. Like always, I want you to take some time and think about, reflect upon what you've seen and learned over the course of this video, and then see if you can use your newfound knowledge to answer your questions down at the bottom of the page. I will warn you to be careful, because some of these questions involve not only our properties of the centroid, which is our new point of concurrency from today, but also the properties of our old point of concurrency, the circumcenter.